is going to deal with the idea of similarity. And similarity takes us back to the idea of transformations and the idea of dilation. So back when we did our transformation chapter, we talked about dilation, which we said was an enlargement or a reduction of the original image. Similarity is exactly that idea. It's just another way of organizing it. Now, in similar polygons, and we talked about this with dilation, the corresponding angles did not change. So for example, very quickly, if I drew, let's just draw some random triangle here, because triangles are nice and fun to work with. So here's a random triangle, and I'm going to clone that and enlarge the clone so it's bigger. What we notice is that the corresponding angles are all congruent. The corresponding angles do not change size. Okay? What we have is an enlargement or a reduction. So the corresponding angles are congruent, but the corresponding sides are proportional. And that ratio between the corresponding sides is what we call our scale factor, K. And you'll notice that in the definition here, scale factor K. That's the ratio of the corresponding sides. And all the corresponding sides will reduce to exactly that same ratio, K, that scale factor. So this is what we're going to be working with similarity. We're going to be spending this entire chapter talking about similar figures and finding proportional sides and scale factors and that sort of thing. So very simply, if I have two figures here, and we're told that they're similar, please note that the symbol for similarity, by the way, is just a little squiggle line. It isn't the full congruent sign. The full congruent sign is like an equals and a similar sign. It's just a similar sign. They are not the same size. Okay? By the way, when we name similarity, again, just like before when we did with congruence, it has to be in corresponding order. So this means angle R corresponds to angle X. They're congruent. S goes with Y. T goes with Z. So those are the congruent corresponding angles. It also means the corresponding sides are proportional. Now, what we do is we go ahead and start looking for the scale factor. To find the scale factor, I find the corresponding sides and set up a ratio. Notice it says RST to XYZ. That means the RST is going to be on top because that's first, and this is going to be on bottom because it's second when we're setting up our ratio. So RS is the shortest side, 20. That goes to the shortest side here, 20 over 12, which reduces to what? Well, 4 goes into both of these, 5 over 3. The next pair of corresponding sides is the medium sides, 25 and 15. 5 goes into both of those. They reduce to 5 over 3. Next, we look at the longest sides, which is 30 over 18. 6 goes into both of those, and guess what? It reduces to 5 over 3. All three sets of ratios reduce to exactly the same thing. That guarantees me that those shapes are similar because they all reduce to the same thing, and 5 to 3 is the scale factor. Now, I went further than I needed to here. Since we were told that they were similar up here, I could have just reduced one of them. But I wanted to demonstrate that all of them are going to reduce to the same thing. It doesn't matter which one you choose. But you have to pick corresponding sides when you're creating that. If I do 20 over 18 non-corresponding sides, I'm not going to get the 5 to 3 scale factor, and that would be a wrong answer. Corresponding congruent angles, we've already done that, and the ratio of the corresponding sides, statement of proportionality, okay? If we want to write a statement of proportionality, what that means with that, when it asks for that, is we say this, RS over XY equals, and we just take it off our statement. ST would go with YZ equals, and then we go RT, first and last, XC. Don't even need the picture. All right. This time, what I'm actually going to do is we're just going to go ahead and I'm just going to ask you to identify what the scale factor here is. Okay? And that's our first question of the day. What is the scale factor? And I'm going to go scale factor only small to large, okay? So JKL to PQR. Hint, that means that the smaller number has to be on top, but in the multiple choice it always will be. All right, corresponding lengths in similar polygons. We can use the fact that it's proportional to set up very simple equations in the form of proportions in many cases to find unknown lengths. This is not a really, really difficult concept. The biggest thing here is consistency. To find the value of x, I have to find which side x compares to. X here compares to a 30 side. Okay? So x over 30 equals, and then I can pick which pair of sides I want to go with. I could go with the 15 corresponds to the 18, so I go 15 over 18. Or I could go equals 20 over 24. I don't have to use both, I just have to pick one. I'm going to go 15 over 18 because those are slightly smaller numbers. Now, I could cross multiply and solve right now, but my numbers are going to get pretty big because 15 times 30 is 450. That's not so awesome. But what I can do is I could reduce this to the scale factor. So I could say x over 30 equals 15 over 18. 3 goes in both of those. That's 5 over 6. And now suddenly I've got a much easier problem to solve because I notice that since 30 is a multiple of 6, 5 times 6, that 5 times 5 is x, so x must be 25. We can use equivalent fractions. If we didn't want to use equivalent fractions, we would go ahead and do our cross multiplying. 5 times 30, 150 is 6x, and then we divide by 6. X is 25. So in this case, it worked out really nicely with equivalent fractions. It's often brought up to me, well, what do I do if I don't have whole numbers in my scale factor? What if I have like a 1.5 to 4.5 for two sides? What do I do with that? Well, move the decimal over by multiplying both by 10. 15 over 45, and then reduce it. That's the way to handle decimals if they're in there. That's a little side note. All corresponding lengths in similar polygons exist at the same scale factor. So it doesn't matter if they're corresponding side lengths, corresponding altitudes, corresponding perimeters, corresponding medians. It doesn't matter what they are. If they're measured in units of length, all corresponding lengths have the same ratio. So here, if I'm trying to find SP or PS, all I have to do is find one pair of corresponding lengths. Well, first off, what does PS correspond to? Why don't we start with that? PS corresponds to PY. So PS I'm going to call X over 20 equals, now I just have to set up another pair of corresponding sides in that same order. Now, since the X came from the triangle here on this side, my top number here also has to come from this triangle. It could be any length measurement for which I know the corresponding measurement in the other triangle. So I could go TS, SR, or TR. Let's keep it as simple as we can. Let's go TS. So TS is 6 compared to TS would correspond to XY, so that would be 8. I could make my life easier because this is a nice number. It reduces. 6 over 8 becomes 3 over 4. I could then cross multiply, get 4x equals 60, so x equals 15. And I know my length. Not super difficult. Do I have to reduce before I cross multiply? Absolutely not. I could have gotten 8x equals 120. I just have bigger numbers to deal with. Just makes it more likely I'm able to do it with mental math rather than having to whip out a calculator if I have smaller numbers, but bigger numbers work just fine. The nice thing about reducing it is when I reduce it, I do establish there's my scale factor. So if I have to do any further calculations for corresponding sides, I can go ahead, or corresponding length measurements, I can go ahead and use that scale factor right away. What I can't use the scale factor on, of course, is angles. Scale factors only apply to length measurements. Length measurements. Included in length measurements are perimeters. Perimeters are a length measurement. So the perimeters exist at the same scale factor as the corresponding sides or the corresponding diagonals or the corresponding altitudes or whatever other lengths there are in the figure. So the ratio of, say, the perimeter of KLMN to PQRS, so the perimeter of this compared to the perimeter of this is the same as the ratio of any pair of corresponding sides, the same scale factor. Application problem. Tom plans to build a new swimming pool. This has nothing to do with our current thing. This is actually on the thing, so please don't read anything into this with our current topics of possible new high schools and things like that. Tom plans to build a new swimming pool. The Olympic pool is rectangular, and it's 50 meters long by 25 meters wide. The new pool will be similar in shape. It will have a length of 40. Find the perimeter of an Olympic pool and the new pool. So my new pool is going to be a little smaller. It's only going to have a length of 40 meters. So if it has a length of 40 meters, the scale factor is going to have to be 50 to 40, which of course reduces to 5 to 4. By the way, scale factor is never a mixed number. So it can be an improper fraction, but it's never a mixed number. So it says, what would be the ratio of the perimeters? Well, I could do this two ways. I could actually find all the sides. I could say, okay, this is 40, and this is 40, and this is 20, and this is 20, and I could go ahead and add them all up. I mean, it's pretty easy to see. They're pretty simple numbers. Or, I could just find the perimeter of this bigger pool. 50 and 50 is 100, so that's 150 meters as a perimeter. And then set up a proportion. 150 over the perimeter of the smaller pool is the scale factor. And then cross multiply. 4 times 150 is 600 is 5x, so x is 120. And I'd know that the perimeter here of that pool is 120 meters. So we could find all the sides, add them up, or we could use the scale factor to set up and solve an equation. Final question for you today, find the unknown length. Don't find the perimeter. Well, actually, no, let's go ahead and find the perimeter. Let's find the perimeter of gazebo A, as it says. So I don't need to find x necessarily here. Okay? We really don't need to find x. I want to find the perimeter of gazebo A. So the figures are similar in ways which are obvious. They are aligned the same way. We don't have to worry about flipping or anything. Go ahead and find that perimeter. That's your final question of the day. See you in class.